So we're going to implement two algorithms for sorting. And let's do this. I'm going to keep I don't need my output. I'm just going to keep my console open. Let me get rid of my HTML. And what I'm going to do here is I'm going to implement bubble sort. One thing we know about a bubble sort is that a bubble sort doesn't need to necessarily create a new array. We can actually modify the array that gets passed in, so that's what we're going to do here. So let's say that I started out with an array, and I'll say that this array is, 9, 11, and 1, something along those lines. So if I end up calling bubble sort on the array, I'll do console.log array. Here I could see, obviously, nothing ended up changing here. So bubble sort, again, we're going to, at a worst case scenario, again, I'm not going to worry about optimization at this point. Worst case scenario, we're going to have to loop over for how many elements we have in the array. And you sort of saw that with the example. Like, we're going to end up bubbling up once to the top, for the first element and sort of keep on going. So I'm just going to do a fairly simple loop here. And I'll go over here and I'll say for var I equals 0, I less than the array dot length, I plus plus. And here I'm going to do a j equals 0, j less than array dot length, j plus plus. Sort of missing part of my screen here. Hang on a sec. Maybe because the output is not here. Okay. So I'm going to run this whenever I want to run it. Let me just make it a little bit bigger. Sorry about that. Okay. So let me also put in my console.clear. Okay. So if I go to run this, right, nothing is really changing here. And what I'm going to end up doing here is that I'm just going to, again, worst case scenario, I'm going to go through this thing, I'm going to have these two for loops, one for the number of elements that is in the array, and then I'm just going to keep on looping, on this inner loop. So I just can ask the question, if array j is greater than array j plus 1. Now I know that I need to do some kind of swap here. And so one of the things that I could do, so first of all, there is one thing that I want to do because I don't want to get an error. Since I am going to j plus 1, I don't really have to go through the whole length, right? I'm going to go to the length minus 1, right? And so, again, if I end up getting to here, if I just did a I'd see a whole bunch of numbers come down here, right, that I'm basically looping on. And what I'm going to do here is, if this is the case, this is, again, one thing that sometimes trips people up, is that I'm going to create this temporary value, and I'm going to create this temporary value for whatever array j is, because I'm going to blow it out of the water, right? And now I'm going to say, so my temporary value is going to be whatever array j is, and now I'm going to say array j is equal to array j plus 1. Okay? And now I could go and I could say array j plus 1 is equal to this temp value. And if that works, I should end up with a sorted array. So this, again, this is very, very much sort of brute strength. If there was one optimization you could write off the bat, we know that every time that we end up going through this, where we know that the change has bubbled up, so theoretically we could do a minus I over here. But the big factor that we're going to see, so if I end up just to, the big takeaway here is that you have a loop within another loop, and that's the thing that's giving us this this n squared. Now, that really is sort of the basics for the bubble sort. Again, we could have put something in here that says, hey, look, did we loop over all these guys? And if they were in order and there was no change, we could, break out of this. That's fine. That's an optimization you could end up putting onto the algorithm. If someone asked you about it, you could, figure that out. But again, we're going to do sort of a minimal thing here. The one that I want to sort of really focus on is going to be the merge sort. So let me go over here. And here I'm going to create a merge sort. And this, too, is going to get an array. And so with merge sort, let's go and I will say I'm going to get back a new array with the merge sort. And I'll say that I'm going to do a merge sort. So here, I'll go use the same numbers. Actually, we'll start out with just, let's say, one number. Console log merge sort of 1, and we get back undefined because nothing is coming back here. If we were to just return the array, we could do that and we'd get 1. Well, let's take care of our end case first, and then we'll build this out. So what's our end case? Our end case is to say, hey, look, if the array.length, right, is less than or equal to 1, it could be an empty array too, then we're done, right? We're merged. We've got a sorted array, we return the array. In which case, this is me, so that ends up working. All right, so I could do that with 1. I could also do it with an empty array, and that makes sense. All right, now let's take the case of having an array of 2 and 1. Right, we get back undefined. Well, what do we want to do here? Well, first of all, what we could do is create a variable called middle, which is going to be the array.length divided by 2, and we'll do math.floor. So in our case, we go in here with 2 elements, we divide it by 2, we end up getting 1, right? So if we were to just return middle, just to see what it looks like, middle is just 1. And what we're going to do is we're going to split our array. And the way that we could end up doing that is we could say left, and this is going to be equal to array slice 0 to the middle, going up to 1. And we could say right equals array dot slice middle, and if we don't put a value in here, we'll end up getting the rest of it. And just to sort of see that, if I return left, I get 2. If I return right, I get 1, right? Because my array is coming in like this. Now, we could easily make the case of here, I mean, we know in our example that this is going to give us a left and a right. But imagine what we do is that we call merge sort again on this array. Okay? So again, we're going to go into the call stack recursively and just see if this seems reasonable to you. We'll go into the call stack. We'll call merge sort on the left, and we'll call merge sort on the right. And then what we'll do here, and this is where we actually have to, generate new arrays here, although actually we're generating new arrays with our slice method as well. What we're going to end up doing here is we'll specify, hey, look, while left dot length and right dot length. So if in fact we have anything in the left and the right, we want to keep on going. Because what we're going to do is that, now right now, again, in our very simplistic example, we've got two arrays, okay? And we want to find out which one is going to come together in the result. So if I go over here, and again, if we, my whole argument here is that if we go one greater than the base case and it works, you're in business, okay? So I'm going to go over here and I'm going to specify that this is going to be our results. And we'll say that if we have a left dot length and a right dot length, then what we're going to do is we're going to say results dot push. And what are we going to push to this? Well, we'll say, hey, look, if left 0 is less than right 0, then what we're going to push is we'll say left shift or right shift. All right, so again, just take our example, take our simple example of just two elements, okay? We call it merge sort again. We've got a 2 on the left, we've got a 1 on the right. We go in here, we end up comparing the left and the right. The left is not less than the right, okay? So we end up shifting off the right, okay? Now in our results, we have the 1 is first. When we go back into this while loop, okay, we don't go back in again because we don't have a length on the left side and a length on the right side. So what we can do here at this point is once we make it down here, we could just return, and just to keep it as simple as possible, we could say whatever our results are, we'll concat left, concat right. Now, if we do this, we should have 1 and 2. Now, if you look at that and you're not really satisfied that that makes sense, right? Just imagine that you have, we go with 1, 2, and 3. Right? This is kind of where you have to go. If it works going down one level, then imagine you have one more element there. We end up splitting in the middle, and we're doing math.floor. So we've now got a 2 on our left. We've got a 1, 3 on our right. You already know that we can end up doing a merge sort on 2 elements. Okay? So again, it goes in recursively. And again, since it worked for 2 elements, it's going to work for 3 elements, 4 elements, 5 elements, however many elements you have. And that really should be the solution to that. Again, you could do some optimization. I know that there's, in the video, there's a way to do this without shifting, because shifting could end up using up some more memory or this sort of thing. But in the end, again, this sort of works and satisfies the concept. Again, bottom line for this is that, one more level than the recursion, one more level than the base case, and that's really about it. Again, we could think about this thing going through with, here, if we wanted to think about it, right? If we had 2, 5, and 1, right? Again, this ends up, we know it works for 2 elements, so we split this into 2 and to 5 and 1. The right's going to be merge sorted, and we're going to get 1, 5, okay? And then we're going to be comparing 2 and 1 and 5, and we're just sort of pulling these off the front of each of these and getting our results when when one of those lists has been totally depleted, which could happen, right? We end up just concatenating the left and the right. Again, we could figure out which one of these has a length left to it, but this is really I think the heart of the algorithm. Anyway, let me save this.